The story of NASA's mission to Pluto begins not with triumph, but with a quiet, almost haunting question. What if everything we believed about the edge of our solar system was wrong? For generations, Pluto existed as a symbol of distance and insignificance, a lonely wanderer drifting through darkness so deep that sunlight itself arrived as a weak, dying glow. It was easy to imagine it as a frozen graveyard of rock and ice, untouched by change, unmoved by time. But beneath that assumption was a deeper human tendency to underestimate what we cannot clearly see. And so, when the spacecraft New Horizons was launched, it carried more than instruments and cameras. It carried the weight of human curiosity, the need to confront the unknown, and the possibility that even the coldest, darkest places might still hold the pulse of something alive. For decades before New Horizons ever left Earth, Pluto's identity had already begun to unravel. Discovered in 1930, it was celebrated as the ninth planet, a distant member of our cosmic family, but over time, astronomers uncovered a startling truth. Pluto was not unique. It was part of a vast and mysterious region known as the Kuiper Belt, a sprawling disk filled with millions of icy objects orbiting far beyond Neptune. This realization reshaped our understanding of the solar system, challenging the neat order we once believed in. And in 2006, Pluto was reclassified as a dwarf planet, a decision that sparked global debate, emotion, and even outrage. But beneath the controversy was a deeper shift in thinking. Pluto was no longer just a planet, or not a planet. It became a question, a mystery waiting to be explored. What kind of world exists so far from the sun? And what secrets could it possibly hold? As New Horizons raced through space at extraordinary speed, it became a symbol of human determination. The journey itself was staggering. Billions of kilometers, across a silent vacuum where even radio signals took hours to travel back to Earth. For nearly a decade, the spacecraft moved steadily toward a target that remained little more than a pixel in our instruments. But anticipation grew with every passing year, because scientists understood that this mission was not just about Pluto. It was about rewriting the story of the outer solar system. And when July 2015 finally arrived, the moment humanity had waited for began to unfold. In the first images sent back to Earth, Pluto revealed itself not as a lifeless sphere, but as a world bursting with unexpected complexity. One of the most striking features captured by New Horizons was a vast, heart-shaped region later known as Sputnik Planitia. This enormous plain of nitrogen, ice stretched across thousands of kilometers, its smooth surface almost entirely free of impact craters. At first glance, it seemed serene, even peaceful, but closer analysis revealed something extraordinary. This plain was not static. It was in motion. The nitrogen ice behaved like a slow-moving fluid, rising and sinking in convection currents. Driven by subtle temperature differences, it was as if Pluto's surface itself was breathing, renewing and reshaping over time, in a place where everything was expected to be, frozen in eternal stillness. There was movement, change, and quiet energy. Towering along the edges of these plains were mountains unlike any seen elsewhere in the outer solar system. These peaks, composed of water ice as hard as stone, rose dramatically into the thin atmosphere. Some reached heights comparable to the Rocky Mountains on Earth. Their existence posed a profound question. How could such structures form and persist on a world so small and so cold? The answer pointed to geological activity. Beneath the surface, Pluto was not dead. It was alive with processes that continued to shape its landscape, challenging the long-held belief that distant icy bodies must be inert and unchanging. The atmosphere of Pluto added another layer of wonder. It was delicate, almost ghost-like. A thin envelope of nitrogen, methane, and carbon monoxide that clung to the planet's surface. But what made it remarkable was its dynamic nature. As Pluto travels along its elongated orbit, it experiences dramatic changes in temperature. When it moves closer to the sun, its surface ice begins to sublimate, transforming directly into gas and thickening the atmosphere. But as it drifts farther away, the reverse occurs. The gases freeze and fall back onto the surface, causing the atmosphere to collapse. This cycle transforms Pluto into a world that slowly inhales and exhales over decades, a planet that lives in rhythms far slower than anything we experience on Earth. Perhaps the most astonishing possibility revealed by the mission lies hidden beneath Pluto's frozen crust. Scientists now believe that deep below the surface, there may exist a vast ocean of liquid water. At first, this idea seems impossible. The temperatures on Pluto are unimaginably cold, Yet evidence suggests that heat from radioactive elements within its core could provide enough energy to keep water in a liquid state beneath layers of insulating ice. If such an ocean exists, it would redefine our understanding of where life could potentially arise in the universe. It would mean that even in the darkest corners of the solar system, far from the warmth of the sun, conditions suitable for life might still be present. The reclassification of Pluto in 2006 now appears almost poetic. What was once seen as a demotion became, through discovery, a transformation. Pluto was never diminished. It was misunderstood. By redefining it as a dwarf planet, scientists opened the door to recognizing an entirely new category of celestial bodies, worlds, that are small in size but vast in complexity. These objects, scattered throughout the Kuiper Belt, represent a frontier of exploration that is only just beginning to be understood. Pluto was not the exception. It was the first glimpse into a much larger and more diverse population of worlds waiting to be discovered. As researchers continued to analyze the data from New Horizons, they were forced to confront a deeper realization. Our models of planetary evolution were incomplete. We had assumed that small worlds cool quickly and become inactive. But Pluto defied this logic. Its internal heat, its shifting ices, and its evolving atmosphere all pointed to a more complex reality. This discovery has implications far beyond Pluto itself. It suggests that many other objects in the Kuiper Belt, and perhaps even beyond, could be geologically active in ways we have yet to imagine. The outer solar system, once thought to be a quiet and frozen wasteland, is revealing itself as a dynamic and ever-changing environment. There is also a human story woven into this journey. The scientists, engineers, and dreamers who worked on New Horizons dedicated years of their lives to a mission that would only deliver its most important results in a fleeting moment, a flyby lasting just hours. After traveling for nearly a decade, the spacecraft had only one chance to capture the data that would transform our understanding of Pluto, and it succeeded. This achievement stands as a testament to human perseverance, ingenuity, and the relentless desire to explore. It reminds us that even when the odds are immense and the distances unimaginable, we are capable of reaching farther than we ever thought possible. In the end, Pluto's story is not just about a distant world, it is about perspective. It is about how easily we dismiss what we do not fully understand, and how quickly our assumptions can be overturned by discovery. What was once considered a frozen relic has become a symbol of complexity and possibility. Pluto teaches us that the universe is not static or predictable. It is filled with surprises waiting just beyond the limits of our vision. And as we continue to explore the vast expanse of the Kuiper Belt and beyond, we are reminded of a profound truth. The more we learn, the more we realize how much remains unknown. The edge of our solar system is not the end of the story. It is only the beginning of a journey that will continue to challenge, inspire, and redefine what it means to explore the cosmos.